So that last little unit got a little bit long. So I decided to go ahead and pull out just the Lewis symbols so we can talk about this, because Lewis symbols are what I actually prefer to look at as we're looking at the number of valence electrons. And if you understand this idea of valence electrons, it makes the ionic bonding so much simpler. So let's look to see what a Lewis symbol is. So on this one, you'll see that I have Lewis symbols and Lewis structures, both of those terms used. And I'm really bad. Sometimes I use those terms interchangeably. A symbol usually indicates just one atom. A structure is when you put multiple atoms together for a particular compound. Don't worry about that. It's not that important for that distinction isn't important right now. What is important is that you know how to draw Lewis symbols. Now, the Lewis symbols are these little notations. So we're just trying to draw something. We're only going to look at the valence electrons. Remember, the valence electrons are in the outermost shell, and that's what's actually going to show the reactivity of different elements. We arrange these valence electrons as dots around the element symbol. And the symbol is just the letters off of the periodic table. To do this, we're going to follow what's called the octet rule. Wow. So let's go back to your Greek knowledge here. What does that prefix oct mean? Well, of course, it means 8. So what this states is that we find that atoms tend to react. They can gain, lose, or transfer electrons because they want to have 8 in their outermost shell, in that valence shell. So let's look at a few examples. So let's say I want to look at hydrogen. Well, you're going to say hydrogen is shown just with an H. And you find hydrogen on the periodic table. You'll say, oh, well, hydrogen, that's in group 1A. It gets 1 valence electron. So I'm going to draw 1 dot on the side of hydrogen. Now, they can be left, right, top, bottom, doesn't matter at all. We're going to have up to 8. They are going to be put in 4 groups of 2 or 4 pairs, but you leave them unpaired as much as possible. Now, hydrogen just had 1. Well, let's skip ahead just a little bit. Let's look at, say, helium. Oh, that's not the one I really wanted to do. Let's not do helium right now. Let's look at neon. We're going to look at your neon lights that you have in your house. Now, neon is in group 8A. So how many electrons does it get? Oh, you are right, it gets 8. Now, remember, we're going to have, we have the top, bottom, and the right and the left. We're going to leave them unpaired as much as possible, but we're going to put a total of 8. So we start filling it out. 1, 2, 3, 4. And then I'm going to start pairing them. 5, 6, 7, 8. Now, neon has a completed octet. A completed octet, meaning that it has 8 valence electrons. Now, there is no place else for an electron to go, so neon is very, very stable. Hydrogen, if you notice it over here, hydrogen just has 1 valence electron. It is not stable. Now, earlier I had mentioned helium. Helium has 2 valence electrons. I've seen helium written with a 2 on opposite side. I've also seen helium, and you only do this with helium, where they're on the same side because they're in the same shell. Helium is a little bit of like an exception to the rule. Helium follows what's called the duet rule. Duet referring to the fact that it likes to have 2. That's the only time you're going to see them on the same side. So, I hate to even put it on that slide. Well, let's look at some more examples. Let's look at aluminum. We talked about aluminum earlier. Aluminum is in group 3A. It has 3 valence electrons, so you're going to put 3 dots around it. Doesn't matter which sides you put it on, just make sure that they're on 3 different sides. That's its Lewis symbol. Fluorine. Fluorine is in group 7A. Here's fluorine, so we're going to go 1, 2, 3, 4, 5, 6, 7. It has 7 valence electrons.
Well, how about magnesium? We're going to get something actually in group 2A, actually has 2 valence electrons. 1, 2. Now, it could be top and bottom, it could be top and right, top and left, left and bottom, whatever combination you want to do. Just make sure that those two are not on the same side. Helium was a weird one, so that's why, yeah, helium was a pain in the butt. Let's see here, a few more. Let's look at oxygen. Oxygen has, it's in group 6A, so 1, 2, 3, 4, 5, 6. Group 6A has 6 valence electrons. How about krypton? Krypton. Superman might be scared here. It is a noble gas. It has 8. 1, 2, 3, 4, 5, 6, 7, and 8. All right, so practice these a little bit. The better you are at these, the easier the next part's going to be. But I promise I will go over a few over the next in the next little section when we talk about ionic, and you'll see why things will bond together the way that they do. Well, I figured you need just a chance to do a quick little poll. This one says how many total electrons and how many valence electrons are in an oxygen atom. I have 8 and 2, 8 and 4, 8 and 6, 8 and 8. Ooh, good question here. Total electrons and valence electrons. Now, sometimes students will get these confused. There is a difference between total, meaning that's all of the electrons in the entire atom, and valence. Valence is just how many electrons are in their outermost shell. So the way that you tell a difference, so go to your periodic table, find oxygen, and you'll see that the number listed above the oxygen is an 8. That means that oxygen has 8 protons. And because it's neutral, it has 8 electrons. So 8 total electrons. Now, valence electrons are only those in the outermost shell. Now, you could draw a Lewis symbol to help you with this, and you'd say, oh, look, oxygen's in group 6A, therefore it gets 6 valence electrons. You could also look at the electron configuration, where you would say, oh, it has 8 total electrons. The first shell always gets 2, and any that are left over goes into the second shell up until 8. So we have 2 in the first shell, 6 in the second. There's 6 valence electrons. So your correct answer should be C, 8 total, 6 valence. So remember, I really like the Lewis symbols. Again, sometimes I call them Lewis structures. Here's a question about this one. A dot must be used to represent every electron in a Lewis structure for an atom. True or false? The correct answer is false. Yes, the dots do represent electrons, but we don't write in every electron. We only show the outermost electrons, the valence shell of electrons, because it's those valence shell electrons that are responsible for the reactivity.